Today we have Professor Ramesh Raskar, who is an associate professor at MIT Media Lab, who is going to talk. Ramesh, it's a pleasure and honor to have you join us today. Let me introduce you to the audience briefly, if it's okay with you, and then I'll pass the podium to you. Ramesh is an associate professor at MIT Media Lab and directs the Camera Culture Research Group. His focus is on machine learning and imaging for health and sustainability. They span research in the physical, digital, and global domains. By physical, he means sensor and health technology. Digital means automated and privacy-preserving machine learning, and global includes geomaps and autonomous mobility. At MIT, he has done an amazing set of co-inventions. Let me just tell you a few of them, which I find really intriguing. They include camera to see around corners, femtophotography, automated machine learning, low-cost eye care devices, novel CAT scan machine, a motion capture system called Prakash, long-distance barcode readers, 3D interaction displays, and new theoretical models to augment light fields to represent wave phenomena and algebraic rank constraints for 3D displays. His work has appeared in New York Times, CNN, BBC, News Scientist, Technology Review, and several technology news websites. His invited and keynote talks include TED Talks, Wire, TEDMed, DARPA, Wait What, MIT Technology Review, Google Solve for X, and several TEDx venues. He has co-authored books that include spatial augmented reality, computational photography, and 3D imaging. And this last one is under preparation. Ramesh also serves on our advisory board for the NSF Prepare project that James is the program lead for at NSF. And Ramesh, we appreciate your support and your advice as a part of that. I happened to interact with Ramesh over the last 2 years, and I'm just amazed at the diversity of his work. And I'm looking forward to this talk, Ramesh. So,
fantastic. Thank you, Madhav. And thank you for the community for having me. I'm going to talk about the fog of the pandemic and the haze of data that makes it confusing for us. Even today, we are confused, whether we should get the fourth shot, should we wear the mask, should we vaccinate our kids who are under age of 5, which vaccine is better, and so on. And we continue to live in this fog of the pandemic. When we are faced with such confusion on a daily basis, just to get from point A to point B in our vehicles, what do? We use Waze or Google Maps or your favorite navigation app. And the interesting part about Waze is that it's a great example of crowdsourcing. And it allows us to self-orchestrate. And it doesn't matter whether you're rich or poor, which car you have, or whether you live in a city that has great traffic lights or not. It's an equalizer. It allows us to use Waze to self-orchestrate. So we have been in this pandemic for so long, and we have been reliant on always external systems. Maybe there's a great health organization, maybe there are great hospitals, or maybe there are amazing science behind vaccines. And we always seems to be waiting for this. But maybe the answer is right in our pocket, which is our smartphone. The way Waze works, just to be a 30-second tutorial, is that Google, which owns Waze, encourages us to share our GPS data in real time for our vehicles. It's centrally analyzed, the traffic density, and that information is sent back to us to provide us information of where the future traffic jams could be, and then also provide us a highly personalized turn-by-turn navigation, and also a global view of where things are. So imagine if we can have a Waze-like app for our pandemic journey as well, all the way from exposure and symptoms and treatments and vaccination and side effects and potential long-term COVID impact. So what would an app like this look like? This has actually been done in some Asian countries where they managed to use all kinds of apps and mobile phone-based solutions to tame the pandemic in a matter of days. South Korea is a good example. Unfortunately, many of these solutions slipped into what we would worry about, which is it very quickly slips into a surveillance state, a big brother solution, and many times these apps, although they are helpful for coordination, also get used with coercion. So the question is, can we use mobile phone apps so that they preserve individual dignity, doesn't create a big brother environment, and doesn't force individuals to do certain things like monitoring their activities or forcing their quarantine or using a green red system for allowing them to certain activities and so on. Right at the beginning of the pandemic, we started, a lot of my research at MIT is about computational privacy. And we started calling folks and we said, hey, we could probably create the self-orchestration Waze apps for the society while maintaining, complete privacy. And it was a hell of a journey because within days, we're talking to CDC and many state health officers with WHO. We started releasing app from MIT, and there was just a massive team of people. Within a few days, we have 1,000 people working with us, contributing to open source and trying to figure out what it should be. We put out some papers, white papers. The first one is called Apps Gone Rogue for the pandemic journey. And we basically wrote down a white paper on all the different ways such self-orchestration apps could go bad and what are some design features for such an app. At the same time, we're developing an app that prevents those pitfalls. So what I'm going to share with you is basically kind of very humble learnings of a computer scientist and about 1,000 people, professional volunteers from MIT, from Harvard, from many parts of the world, many companies who contributed their employees, a really humble journey of what we as idealists thought we could do, what actually happened, what we could accomplish, which was very significant, but still compared small to what our ambitions were, and how that played out, and what we can learn from this going forward. So long story, very short, which is that within a month, MIT basically said, if you're doing something that's consumer facing, you cannot do it under the MIT brand. So we spun it off as a nonprofit called PathCheck Foundation. We raised a few $1 million. We also got funding from NSF in the beginning. Thank you, James. And also spun out this nonprofit, raised a few $1 million in philanthropic funding, created a very large software team, and very quickly became the world's largest open source nonprofit for privacy preserving solution for COVID-19. And then over the next few months, our open source solution started getting used in many places, in many parts of the world. Some of them we knew, some of them we didn't even know, and we would just hear about it in news. But officially, under our own umbrella, we launched official government solution in 5 US states and territories: Louisiana, Alabama, Minnesota, Hawaii, Guam, and also countries like Cyprus and so on. And as I said, it was a humbling experience of getting the solutions out there in the middle of a pandemic when all of us are also impacted at home at the same time. Let's talk about what it means to create such apps. So imagine there's John, and he is a undocumented worker in Sao Paulo, Brazil. He goes to an event, he gets exposed to the virus. A few days later, he has symptoms. He figures out that maybe it's better for him to isolate and maybe get tested. Then he goes to a local pharmacy and gets some over-the-counter treatment. Hopefully, he doesn't get hospitalized. At some point, he sees opportunities to get vaccinated. In the beginning, undocumented individuals had no way to vaccinate because they must show their ID to get vaccinated. But eventually, he figures out a local church that allows you to vaccinate without asking for your papers. Now, through this pandemic journey of John, for the rest of the public health, he's completely invisible, right? And he doesn't get early alerts. He doesn't know which treatments are best for him. And if there is Jane, who is a public health researcher, also has a blind spot because she cannot see John in her journey. It's not in any electronic health record as such, unless John is hospitalized. So it's very difficult for her to see how the disease is spreading. Which pockets of Sao Paulo are getting impacted in what way. So for her to provide data to the government about how we should deal with quarantine and lockdown policies, whether you should shut down the whole city or should shut down, certain districts, or should you shut down only the restaurants and bars, or should you shut down the public transport, is unknown to her. So most likely she's just going to promote a one solution fits none type strategies, like lock down the whole thing. And then she's hearing about all these treatments that are coming online, whether she should use hydrochloroquine, malaria medicine, or this GV's pharma product that's been released with a clinical trial that's had only about 100 or 200 participants, not the right age group, not the right ethnicity. And that's maybe they should provide an emergency use authorization. And she also has no idea whether the public health resources are being utilized with some equity. Is it going to the demographic that may be most impacted and may not have the resources to do it, especially people like John or undocumented daily wage workers? So it's a lose-lose on both sides. For John, his journey through the pandemic is a fog. And for Jane, lack of data creates the haze. So this is the challenge that many of us will identify with. All through this pandemic, if you look at these different stages of exposure, symptoms, treatments, side effects, longitudinal effects, we always hear about the statistics and hypothesis much later than we should. So for example, in November of 2021, we heard about the new variant, Omicron, and we all got concerned from South Africa. I mean, the US stock market went down, policies changed dramatically, but we didn't know how transmissible it is. And we didn't know that although it's transmissible, it's less virulent and so on. It took 2 to 3 months before that data started coming out and verified. So how worried you should be to an exposure like that takes too long. There are many of the questions that kind of bother us, right? So for example, the symptom timeline between different variants, Delta versus Omicron, is odd. I had COVID last month in April myself. And if I have to just figure out a symptom trajectory, like, okay, on day 2, I start getting fatigue. On day 4, I get a fever. On day 5, if my fever goes down, does it mean I'm going to get better? With what probability? Is it the 80% chance that I'm going to get better and better? Or the fact that my fever went down is a very common symptom. Maybe it could come back on the 6th day. Or that I have nausea or I have loss of taste. Is that supposed to happen on the 5th day, or is it supposed to happen on the 8th day? And so on. So you have this haze of data. Even today, you cannot go online and see a plot that shows that incubation is X number of days. And after that, this is what your trajectory of symptoms could look like. On 4th day, if you have fever, then there's an 80% branching of fever, not fever. And after that, there is a 20% branching of nausea or not, and so on. So there's no such graph that shows the symptom trajectory for us that anybody can follow and just enter their symptoms on day 3, 4, 5 and get a sense of what's the probability, what's the chance of getting worse, getting better, or should they take Paxlovid early or not, and what's the impact of taking a particular medication early or later. And then we had all this confusion about malaria medicine and hydrochloroquine, and it was just anecdotal in many cases. The clinical trials did come around, but the clinical trials only had about 100 people, maybe 200 people in it. And so the conspiracy theorists would always say, hey, those trials are so small in size, there's not much we can say. Or the fact that Paxlovid is actually so powerful, so helpful in reducing hospitalization was understood much later, statistically. Very recently, we heard that 30% of COVID deaths are among diabetics. Why didn't we hear about this for 2 years? We just heard about it very recently. So diabetics would have put ahead of the queue in all kinds of treatments if you knew that. And the first thing you would do is measure your globin A1C. But we didn't do that. What about vaccine side effects? I know there are sites like CDC has a sites like VAERS, VAERS, for adverse events and so on. And of course, there's VSafe, which is an SMS-based system for getting feedback. But the challenge is, till this day, our data on side effects is very poor. If you go to the VAERS website, it shows a lot of people die within literally a week of getting vaccination. And we created a dashboard for it at the PathCheck Foundation. You can go check it out, vax.pathcheck.org. And we are very concerned about putting this dashboard that was taking the CDC data on a daily basis and plotting it because nobody else was doing it, because we're worried that anti-vaxxers would use that website to demonstrate how many people are dying, including children, within a week of vaccination. And the problem with that data is that it's unverified. So anybody can call in and say, hey, my cousin who lives next town died after vaccination. So this data is very unsophisticated in that sense, although the statistics is available. It would have been great if every individual had some kind of a hash, almost like a social security number that can be used only once. So it's a one-way function with simple cryptography, so that it's very easy to verify what these cases are. And those of you who come from the field of clinical trials and pharmacovigilance and so on, there are 4 pieces of information that are required to do this analysis. And often all those 4 pieces are not available. So that's a problem. More recently, we heard that J&J vaccine has been stopped or discouraged for folks under 18. This is problematic because it has come so late in the game, this information, that again, conspiracy theorists are going to say, wow, this is exactly the reason why we didn't want you to get the vaccine, when in reality, the J&J vaccine actually impacts a very tiny fraction of folks with thrombosis risk. But again, under 18, over 18, that data was not available. Longitudinal effects. Just yesterday, CDC put out a major paper that said that long COVID can impact 20% of people under 65. That's a significant number. And this is mostly for heart and lungs and other cardiovascular health, kidneys. So this is quite surprising that after spending billions of dollars on science and suffering through trillions of dollars of economic upheaval, that information like this is not available on a real-time basis. And often it takes several months, even for things like Omicron and its transmissibility, and often years, if you think about the J&J vaccine and the long COVID monitoring. So we could do much better than this, right? Those of us who think about data, it's obvious that poor data leads to wrong policies and wrong strategies. And when you try to implement them or you're trying to enforce them and you don't see the results for things like lockdowns or forced vaccination credentials and so on, then it leads to very low trust and low adherence. And the cycle continues, right? This is the big challenge we have seen throughout this pandemic. So without citizen engagement, you have this loop where you would think that with test, and vaccinate programs, you will create evidence-based data, and that will allow us to predict what the right policies are, and you would deploy them, and the public would see its effect. It will build trust. We can send them alerts, and they will adhere to those policies, and they will continue to participate in test, trace, vaccinate programs. And this flywheel will allow us to deal with the pandemic. And this is how we saw it work in countries like South Korea and Taiwan and so on. The problem is, without citizen engagement, this loop breaks down. And Jane also doesn't have this information to actually create the corresponding analysis and alerts, right? So this is the challenge we run into. And as hard as we can try to use a system like we see in Israel or UK, where you might have a centralized electronic health record system that allows you to see it, the challenge is that majority of activities in a public health crisis stay in the public domain, which is they don't become data in a classic sense of medical, clinical, or health systems, as you saw in case of John. So this is where it breaks down. When there are data gaps, apps can fill those gaps. So the blue boxes here, if we can engage the citizens, then we can capture the data from them. And Jane can use that supposedly low stakes data about exposures, about activities, about treatments, over-the-counter treatments, and predict how this disease is spreading, what are the best solutions. And she can analyze this contributed data in addition to non-crowdsourced data such as EHR and clinical data. She can analyze it and she can create an alert and then give not broad guidance like having a press conference every day or sending messages through TV and newspapers or creating one-size-fits-all campaign saying everybody should lock down or everybody should wear masks and so on, but create highly personalized messages where you would get an alert on your phone, much like you would get an alert for a new deal on an e-commerce site. You would get an alert if you entered your information saying, hey, I'm 60 years old, I'm diabetic, I have this type of a profession, an essential worker, this is how I get exposed, I live in this zip code. Just send me the information that I need. I don't need to read newspapers and look at conspiracy websites to see what's the best information for me, right? So that would be an ideal solution to have apps to fill the data gap. And what I'm saying is there's nothing new about this concept that if you engage citizens, you can create this flywheel and you can have extremely engaged population and at the same time be able to deploy solutions that will actually have an impact, right? This is an open secret for any big tech companies. I took a sabbatical leave from MIT and started a health innovation team at Facebook. I was at Apple on the privacy and the health team. And earlier in my career, I was at the Google X. What I've seen, and we all know that these companies that are consumer facing become worth trillions of dollars using one simple formula, which is they encourage us to participate in their ecosystem, mostly through apps. They capture our data, they analyze, and they figure out how to give highly personalized solution for us. Whether you use an Amazon app to see what products they're recommending, whether you're using Uber to hail a ride, these are highly personalized solutions. At the same time, they're crowdsourcing data from all of us. So an obvious question here is if every sector, transportation, e-commerce, energy, finance, and so on, all these players have figured out that through apps, we can engage citizens and create highly personalized solution. Why don't we do this for public health? Why do we spend billions of dollars without creating apps? Let's look at one common example that we all will resonate with, which is Waze. So same formula here. Google or Waze encourages us to share our GPS data, and in return, we get instant benefits of looking at traffic ahead. And in my opinion, there are 4 things that need to go right for such crowdsourcing and personalized guidance apps to work well. These are the 4 things we care about. Privacy, that Waze solves through branding, because it's completely anonymous. You start the app. It's ease of sharing. You don't have to fill up a form. You don't have to identify who you are. You don't have to tell which car you use. You literally open the app and immediately start using. And to even share the data, you don't have to fill up a form. Google is sucking up your GPS coordinates the moment you open the app. You get tangible benefits. And the fidelity is very high because if there is traffic ahead, you will see a red versus a green. And if there's no traffic ahead, then it will be green. So the trust is built over time. And that's why more and more people start using it. And it's also very reliable. The adoption rate, according to some research papers, can be as low as 1% for a Waze app. But that 1% of users can actually compute the traffic density because even one vehicle can go through a traffic junction without waiting for too long. Then Waze knows that there's no traffic jam here. On the other hand, even a small fraction of cars slow down at that traffic junction. It knows there's a traffic jam. This is a very important point I want to make, which is that crowdsourcing doesn't mean everybody has to participate. Even 1% participation is sufficient to get an idea of how a deployed solution is working. So you might have very sparse sensors and very sparse actuations, which is what a transportation system would do. They would put traffic lights at certain places, and then we'll have a centralized location from which they would try to make decisions in the future of where to put more roads, where to put more ramps, where to widen them, where to create U-turns and one-ways and so on. So the activity by transportation department is based on very few sampling points, traffic cams and so on. And their response is over a matter of years to change those traffic rules or to add more capacity to the roads. As opposed to Waze, where the sampling is happening in real time, very dense. Even if you're driving through area which has no traffic cameras, no traffic lights, the information is being collected in real time. And what you would do with it is also instantaneous, because even if I take a standard route to go from point A to point B, Waze can tell me on a given Friday evening that maybe you should take this other route because the route you take on a weekly basis has a lot of traffic jams ahead. This is something we need in public health as well, because in public health, our mindset is that some centralized authority is going to make a decision on how to respond to the crisis. And the sampling we have is mainly from electronic health records in hospital systems or the clinical data coming from pharmaceutical and vaccine makers and so on. And we have to change that mindset to go to a real-time sensing and a real-time feedback for an individual as well. So let's take the example of just vaccines and vaccination. So we saw this heart-wrenching scenes. This one is from Florida, where elderly people who really wanted to get vaccinated started showing up because they were the first ones eligible, and they started camping out in the hot sun to see if they could be first in the line to get vaccinated. So this is a population that really cares about getting vaccinated. These are not anti-vaxxers. We should be fortunate people want to get vaccinated. And we created a maze for them that they had to navigate just to get vaccinated, right? They had to go online, create forms, identify who they are, and so on. And so the disappointing part here is that we spent billions of dollars and created this amazing scientific solution called vaccines, but we spent $0 thinking about the citizen engagement and the citizen experience. And if you think about how it has impacted the elderly, how it has created more vaccine doubters, and how it has made it nearly impossible for us to track the side effect. I mean, some of the best vaccines that were approved only had about 100 positive cases, and that was enough for them to get the emergency use authorization. And that information was used by anti-vaxxers and doubters to challenge effectiveness of these vaccines. And when we started realizing that the longevity of the vaccine is just about 6 months, I mean, I'm triple boosted and I still got COVID within 4 months after my third shot, starts creating doubters even among the people who otherwise would get vaccinated. So without citizen engagement, this whole loop breaks down. And if we had conveyed right in the beginning that the longevity of the vaccine is only 6 months, and that's why we need boosters, we wouldn't have to change the story so many times for public to lose the trust in vaccines. If you look at the new government plan for pandemic response, not from Madhav's team, but the government response, it talks about $65 billion for pandemic preparedness. If you go through the whole plan, the word phone appears only once in the context of sending SMS alerts. And there's no mention of apps at all, right? So again, industries and companies are creating trillions of dollars in economic value by using this one approach, which is creating apps that will engage citizens, that will encourage them to contribute data through crowdsourcing, analyze, and provide them benefits. But our pandemic response plan has no emphasis on creating apps. Now, you would say there were apps, right? There were symptom checker apps, there are contact tracing, and when you check in apps, there's some quarantine pass, there's vaccination credentials. If you go to Asia right now, you have to download apps to do certain things and so on. So these are all well-intentioned efforts. The challenge with all these apps, including the work we did at PathCheck Foundation and at MIT, is that these apps are not connected. So if you compare the 4 metrics that we looked at Waze, are they privacy preserving? No. A lot of these apps, the government insisted that they are branded as an official government app, which was great for us as bragging rights at PathCheck that we released these government branded apps. But who wants to use a government branded apps to track your activity? Ease of using them? No, because all these apps are disconnected. The symptom checking app is different than the contact tracing app is different than quarantine and so on. The information doesn't flow. If I have to get vaccinated, I have to use a completely different app. Then I have to use a different vaccine credential solution and so on. If I have to schedule a vaccine appointment, I have to go to a website. It's a completely disconnected experience. And what are the tangible benefits? On the one hand, we launched this exposure notification apps that give an early alert that if you have been in close proximity of an infected person, but the privacy technology was used in such a way that the information simply doesn't help the public health because they cannot see in real time in which zip code more people are getting alerts or which population in terms of demographic is getting impacted. Is it people in restaurants? Is it people who are working in hospitals? Is it people on public transport? So they have no clue of what's going on. And if there was a super spreader event, they have no way to go back and alert everybody else who was at the super spreader event because the exposure notifications is a piecemeal solution because it only tells you that you were close to an infected person. In fact, I get those alerts all the time, exposure notification alerts. And I'm myself perplexed, although I was one of the first co-inventors and co-founders of this efforts. Like, what do I do with this? Because exposure notification simply says, I was in contact with somebody who was infected in the last 14 days. So these are meaningless alerts now that are coming through. And are they reliable? Even if you take exposure notification, they'll only work if many of the people also use exposure notification app, such as in dense urban areas with savviness with the technology. So if you compare this scorecard with the scorecard for Waze in terms of privacy, ease of use, tangible benefits, and reliability, we're doing very poorly on that scorecard. And this is one of the reasons why, despite the presence of some apps, these disconnected apps, we haven't seen as much impact of them. So what we really need is a single app for pandemic journey. When you use Uber for ride sharing, there's a single app that connects you all the way from the discovery of how long it's going to take you to find a ride, to figuring out which driver you're going to be paired with, all the way to your journey, your safety, and as well as your payment. And of course, your credential and your score. All of that works in a single app. But behind the scenes, as you know, Uber is doing some magic. It has created a full physical infrastructure, all the way from recruiting drivers, doing their background checks, creating centers where they go and check the cleanliness of the cars. They have secret agents who go and ride these vehicles to see everything is functioning properly, and so on, right? So a whole physical infrastructure is out there, but for us as a consumer, it's a single app. And when it comes to public health, we need also a single app. I mean, public health and government is spending billions of dollars to create hospitals where you can get information, coordinating clinical trials, giving funding to vaccine makers, doing research on long COVID. There are thousands of people who are writing papers about the latest information. That's all great. But what a consumer needs, what John needs as an undocumented worker in Sao Paulo is a single app that tells John about whether he's exposed, what kind of treatments might work for him once he has entered his personal information that stays local, that is 60 years old, he's diabetic, and this is the kind of job he has. He also gets alerts on now it's time to get your third booster without relying on your stories. It tells him in real time that, hey, these boosters and original vaccines, we can tell you in advance, have a longevity of only 3 to 6 months. That's why we're asking you to get boosters. And if he does get sufficiently sick, and even if he's undocumented, there are ways for him to go and get treatment without revealing his identity and without putting him at risk for not having the proper papers. And behind the scenes, again, just like Uber is able to do all the analytics and figure out how to do the mapping and look at the density of riders and drivers to do predictions, Jane in Sao Paulo would also benefit from it, right? So there's something simple we're talking about here, which is providing an app. I mean, even the most junior person at MIT, when they graduate, And if they want to start a cool startup, the first thing they think about is creating an app. But in public health, somehow creating an app is considered well outside the realm of tools that we can deploy. So the natural reaction would be to think like traditional public health systems. And this is how it was done with NHS UK, for example, where you would say, hey, we are running a centralized app where we would expect all of you to consent. We have equivalent of a HIPAA. And then what we're going to do is we're going to collect all this health data in a centralized way, and then we can analyze and give you some solutions. This doesn't scale either, right? It's kind of the society of the mind. A decentralized solution with no peak privacy is very critical because, again, when it's centralized, you can very easily slip into a big brother mindset. I'll use the example of Apple Maps for navigation. So I'm not an Apple fanboy, but you know that unlike other maps, if you use Apple Maps, if you go from point A to point B, Apple doesn't know what is A, what is B, and what route you took by using relatively straightforward privacy-preserving algorithms. And the reason why even an employee or a rogue employee at Apple cannot figure out whether a given user started A and B and what the route you took is using certain computational privacy algorithms. And all of this can be achieved using so-called no-peek privacy. So it's not about confidentiality or anonymity like we think about in health systems, but it's computational privacy. Now I'm going to go into the details of some of the algorithmic methods of achieving such a system. But before I do that, let me pause and take a few questions.
I really appreciate the interplay between utterly practical and opening the door for where the technology peeks in. I've seen many, many interesting technology approaches to things, but I don't ever understand how they can be in practice placed oftentimes. And so in this particular case, I have a very simple question about the very beginning of setting up this nonprofit. Is when you raised the money for the nonprofit, what did you spend the money on? Did you spend it on salary? Did you spend it on infrastructure, data? What did the money get spent on?
Engineers, salaries, yeah.
Salaries. Okay, so these engineers operate under some sort of contract relationship with this entity that hands over the IP they create, and you don't have any problems with that kind of thing and so on.
Yeah, we have many professional volunteers, literally hundreds, but software engineering, especially when you deploy a government app that literally affects people's health, has to be professional. So we have over 20 software engineers who worked on it for about 6 months to build enough enterprise-grade solutions that can be deployed by governments. That can be done purely with volunteers, yeah.
And the whole thing is done in an open source style environment?
PathCheck.org. It's all open source. And again, our hope is that we release this open source and other entities will go and build solutions on top of it, very much like Linux and Red Hat or Ubuntu. But in reality, what ends up happening is many states come to us like Minnesota, Louisiana, and so on. They say, that's all great, but can you just give us the app? Don't just give us open source. So then we would actually hire even more engineers to go and deploy those apps. And those governments actually paid us back. So although we raised a few $1 million in philanthropic funding, without our intention, we also made $1 million+ in revenue in the first year.
There are two online questions. One is from Giri. Is it possible to set up applications and dashboards that interact with data across multiple administrations? And there is one from Andy, which is, what is the best way to promote such an app so people know it exists? And Rita really likes to talk. So I think that's great.
So the short answer is that we don't know, right? I can tell you some of our learnings, but we don't know what works because we're in a very new regime in that sense. Just think about how long it has taken for e-commerce apps to become what they are today. It has taken years for them to iterate on low stakes problems like selling books to high stakes problems like getting grocery delivered in 15 minutes, right? So it takes a long time for these things to evolve. And we are in phase 0.1 for public health. And one of the messages I'm going to deliver later is that all these well-intentioned efforts, and I'm an advisor to HHS. I work with lots of government agencies, and the good intentions are that we should create bridges between this monolithic health HIEs, health information exchanges, and we should create protocols for them to talk to each other and so on. These are all good efforts, but they're not enough because innovation, by definition, means that the interoperability will never be a thing. Interoperability is possible when innovation has stopped. But when people are constantly evolving new ways to capture data and exploit the data and deliver solutions, interoperability is always going to be a challenge. So what works better is not just connect those health information exchanges, but to make solutions that actually citizen-centric. Because as long as the solutions are user-centric, they are in charge of how all these systems are going to connect with each other. And that's how before Apple came down on connectivity between apps, different apps on your smartphone figured out how to work with each other without those for-profit entities talking to each other of how exactly they're going to use the data, right? So I'm answering your question in a different way, which is, yes, dashboards and all those are possible, but we want to make it possible in a decentralized manner so that it's citizen-centric and not centered on connecting large EHR data sets. The next few slides I'll go, as I said, I'm going to zip through. They're a little bit more technical, but it just gives you a flavor of what's possible from a technology point of view. So it's kind of obvious that the trade-off between utility and privacy is the challenge here. I know for Waze, for Google Maps, we willingly give away our GPS location, and we get tremendous benefits, like looking at traffic density. But for health data, because of regulatory issues or trade secret issues or even national security issues, we are not able to exchange that data, and that makes it impossible to get benefits from it. So the question for us is, how can we make this invisible data visible using computational privacy? And we want to be in the top right corner in this diagram. And often we confuse what we mean by privacy. Privacy is not what we kind of think about on Twitter or Facebook or something like that. Privacy is not just for an individual, but it's also for an organization and often for a nation, right? So an Asian government is not willing to release the real-time data of how many people are infected in which part of the country and so on, because that's also a national security issue. They don't want to reveal that X number of fighter pilots in the country actually down with COVID right now, for example. So privacy is not just an individual issue, but scales. And also when we think about what it means to provide privacy, as I said, on the bottom right is where health system is, where it's all about protecting confidentiality. But many people can actually see the data, and that's why you get into regulatory issues. And then some companies provide pseudo-anonymity, so you still have a persistent identifier. It's just that you don't reveal your identity, but that's not enough. A better solution is in the greenish circle, which is anonymity, which is how exposure notification work, where you don't have a persistent ID. But what we really need is a solution that not only protects your identity, but also protects your data, which cannot be reconstructed. And this we call at MIT no-peek privacy. And the reason why we should strive to get to the top right, because if you don't have privacy, then you end up creating data silos, because now you have to deal with anonymizations and regulations. And silos lead to low efficiency, and that dramatically increases the cost, not just in terms of dollars, but in terms of lost lives. There are many solutions possible to create this no-peek privacy, either using on-device calculations or using secure multi-party computations, differential privacy, and split learning, which is the invention from our group at MIT. And this can be used in some of the applications I have listed at the bottom, such as exposure notification, risk calculation, that can be done completely on device, or this symptom trajectory, stick weather. And I don't know if Graham Dodge is online, but he's the co-founder of an app called Stick Weather. Now he's the president of PathCheck Foundation that I mentioned earlier. It's been from MIT. Or differential privacy, so that you can upload your data while protecting individual symptoms, and split learning for things like recovery journeys and interventions and nudges, so that you can get personalized nudges, but the system doesn't know what nudge was provided to an individual, right? As I said, when Apple tells you how to navigate, Apple doesn't know what instruction was sent to a particular user. I think on-device calculation is straightforward to understand. So in exposure notification, for example, if John gets sick on the bottom right, he uploads his keys of social contact that has come through GPS or Bluetooth to a collection of servers. And at least they would download those keys and do a local match to see if the GPS coordinate or Bluetooth ledger matches with the GPS coordinate or Bluetooth signals sent by John, right? So completely privacy preserving local calculation. Alice and David never, ever, ever have to upload any data to the server. And this allows Jane to see the caseload by region. Things like risk calculators, which are very critical to give folks some guidance on where the data is coming from, their own personal background. As I said, John can upload, he's 60 years old, he's diabetic, this is his profession, this is his status, and so on. And this activity he's going to do, get on a public transport or go to hospital, and so on. That goes into the central box risk calculator. And then you get highly personalized solutions completely with on-device calculations, right? Download only, no upload. And then you have things like secure multi-party computation. A 30-second primer on secure multi-party computation is that if John wants to convey that he has fever or not, he can send a number 1 as opposed to the third person on the right who doesn't have fever in green, and this person wants to send a 0. So the red phones want to send a 1 to the server so that Jane can compute, how many people have fever. Then instead of sending a number 1, John's phone can send 70 and minus 69 to the 2 servers. And the next one can send 34 and 38 and minus 37, which is the addition of the 2 is 1. And the last one can send 42 and minus 42. And the 2 server can do a local aggregation and then finally send a sum to Jane so that she can figure out that 2 phones indicate they have fever without any individual phone revealing their information, whether they have fever or not. As I was talking earlier, when I got COVID, I didn't know what my symptom trajectory is going to be. But if I had a mechanism to participate in this, saying, hey, on the 4th day, I got Paxlovid, and the 5th day, my fever went down, and the 6th day, I was feeling much better, I can share this through a crowdsourcing solution. But if I have differential privacy, then I can aggregate this symptom trajectory after adding noise locally so that I'm not revealing my own symptom trajectory in its raw form, but still contributing to the overall aggregated information. And this would allow Jane to figure out what treatments are working and how symptoms are evolving for a given variant. And then you have this distributed privacy-preserving machine learning algorithms like federated learning and split learning from our group at MIT, where John might go to a local pharmacy, local medical store, and the local phone can compute a simple machine learning algorithm that says, given his health status and treatments, what is symptom trajectory for John? And that can all be learned. And that would allow Jane at the central office to see which treatments are having what kind of impact for which demographic, right? So all this can be done with computational privacy. So if you again go back to this privacy utility trade-off, there are all this method, anonymity, using obfuscation, using encryption, and so on. But then you have this reduced ability to exploit that data for statistics, for inference, for training machine learning models, and so on. And I'm a little bit biased, but I feel techniques like federated learning and split learning from our group at MIT are the ones that can provide extremely high utility, although it gives up some notion of privacy and security, right? So you're going to have 2 questions right away. One is, but what about adoption? We have heard that you need 60-70% of adoption of these apps to get any meaningful results. That's not true at all. As I said earlier, for Waze, even 1% of the users who start participating can create a flywheel for usefulness for Jane in public health. And what about if there are many apps, would it still work? And the analogy I gave is like the National Weather Service. It doesn't matter which weather app you use. All of them have a different interface, their predictive models, and so on. But they're all connected through a backbone through the data coming from NOAA and the National Weather Service of upcoming threats, right? Individually, folks can analyze the data and then provide personalized nudges for a given consumer. So you don't need monolithic databases to talk to each other to create. You don't need one single app in all the countries, but in every county, every state can have one pandemic journey app, and they can still talk to each other. Another question that's very common is, what about vulnerable population who don't have a smartphone or don't want to share personal identifiable information? So we have written a set of papers. We have deployed some of the nonprofit open source projects have merged with us. I won't spend time on this, but all of this is possible with smartphones. One of our partners in South Africa started creating these QR codes so that anybody who doesn't have a smartphone can still use it. So this is where we are at, right? So what does the PathCheck app look like for this pandemic journey? And I encourage you to go to this website, prep.pathcheck.org, to look at how, for John, the whole pandemic journey can look like, from early warning to symptom checkers to prediction of cases in the neighborhood, getting quarantine support, being able to privately talk to public health, getting highly personalized just-in-time recommendations, having some information about its efficacy so trust is built, scheduling of vaccination, ability to report adverse events using a private mechanism at the same time with credentials so that it cannot be spoofed, like Waze can be spoofed right now, and so on. So I'm going to skip over the screenshots of the app itself. Diary, tracking, queries. And then for Jane, she can also use this information to create sickness maps, spread, efficacy, equity, and so on. And in return, John can get highly personalized feedback in a privacy-preserving way. So this is a lot of the work that PathCheck is doing, and a lot of our work at MIT is creating privacy-preserving algorithms for it. Many folks, when I talk to them, government folks I talk to, they think this pandemic is, in a way, is a rehearsal for unengineered threats of the future, which could be much more lethal, much more focused. And if we have to get such an app out there, it's going to take years to optimize the user experience, change citizen behavior. I mean, right now we understand how to use Uber because we understand the language, the semantics of Uber. It takes many years for citizens to change their behavior. I mean, in the beginning, remember, we all said, like, who's going to get into a stranger's car in the middle of the night? It took us a long time to change the citizen behavior. And we don't have to wait for the pandemic. We can use such apps and have drills and rehearsals with slow-moving threats and not necessarily fast-moving threats, which could be diabetes or other epidemics that are out there. So to conclude, to deal with the haze of this pandemic, we need ways. And to fill data gaps, we need apps. And when we beam information from central authorities, we really need to beam trust. And that's how we can be prepared for the next pandemic. Thank you.
Great. Just a superb talk, Ramesh, as usual.
Thank you, Ramesh. I just wanted to go to Galen first online. I know he had a question. So Galen, go ahead.
Thanks. This is an interesting talk. So I guess I was wondering if you could say a little bit more. One thing I know about Waze and sort of other platforms like this is problems with Sybil attacks, where what this can look like at its sort of most crude point is like you have somebody with 100 devices or a farm with, you can see these pictures of places with hundreds of thousands of like click farming, basically. So I'm wondering how you consider getting around issues like that, because particularly if this is information that is maybe has national importance, some kind of like misinformation or disinformation. I always forget the distinction between the two, is some kind of campaign around that.
Yeah, that's a very valid point. And in fact, as I said, we wrote this paper, Apps Gone Rogue, even before we launched the first app. I think we released the paper on March 12th of 2020, and we released the app on March 15th of 2020. And CDC, in its recommendation to states about using digital solutions, actually recommended our paper as an example. And in that, we listed all these issues of kind of sophisticated attacks against such apps, as well as unintentional misinformation that could be released through such mechanisms. So there's no one single answer to it. I mean, you're familiar with computing techniques to deal with each of these attacks on device, spoofing sensors, secure multi-party computation, where you could have untrusted, unverified participants, differential privacy, federated learning, and split learning. Each of these computational privacy methods have their own ways to deal with many of these mechanisms. But to your point, I think this is a wide open research area on how to make it more and more robust. I think the way it works today is that the Play Store and App Store actually have very robust mechanisms to make sure that an app can only be verified. So it's very difficult, for example, to use an Android app that's not installed on an Android device. And the Play Store actually makes it very difficult nowadays to achieve that. So you cannot create threads on a supercomputer to pretend they're all Android apps anymore. So this has become a much better ecosystem, but relying on the goodness of the Apple and Google ecosystems. But I think if you want a public health entity to deploy this without relying on Play Store or App Store security, all these issues are still a problem.
Giridhar Paul, I see a tech stack mismatch is potentially a challenge when innovations happen.
So here's a concrete example, right? When vaccine credentials we thought are going to come, many well-intentioned organizations popped up saying, hey, we're going to bring everybody on a common platform and we'll create QR codes that can show that you're vaccinated or not. And our solution at MIT and PathCheck is we said, we don't want to worry about interoperability, and vaccine credentials should be more like cash than credit cards. And there should be offline solutions that can be verified by just showing a bitmap or a printed piece of paper, and can also be verified offline using a mobile phone that's not necessarily online, right? Which is like cash, as opposed to credit cards where you need a whole ecosystem to validate if you have money in the bank. And in real time, you're validating this is Ramesh Raskar who's showing he's vaccinated or not, and so on. And what ended up happening is that perfection became enemy of the good. And everybody started focusing on interoperability and having common standards, common protocols, and so on. And we insisted that cash works without interoperability. Whether you have a pound or a euro or a rupee or a yen or a dollar, you can use it, although none of these currencies have a common standard when you exchange cash. So often public health gets into this tangle where I think all the stakeholders have to come on a common platform to create interoperable common standards. And yes, over time, cash should be replaced by credit cards, and you should have common standards for transaction. But in the middle of a pandemic, there's no need to insist on interoperability. So as I said, innovation always beats interoperability, is always ahead. And what we should do is, for parts where we can build those interoperable tech stacks and standards, we should do it as much as we can, but also leave the option open that in the middle of a pandemic, in the next fast-moving threat, we will have to rely on non-interoperable, highly decentralized solutions. And that's also kind of the promise of Web3 to some extent.
Are there any maybe questions here from anyone? Anil?
Thanks for the talk. It was really wonderful. So I have a question related to what Galen was asking. I'm wondering whether there's a trade-off or conflict between the goals of privacy and misinformation. So often there are some fact checkers and so on, like you'd see for find different kinds of data that you mentioned. Is it easy to deal with that once you start including privacy?
Yeah, that's a very good question. So I've spent a lot of time on misinformation, disinformation, and unintentional consequences of information, lots of projects in that space. And if you look at how Amazon and its reviews deals with it, is you have a verified purchaser versus unverified purchaser. So there's a kind of a closed loop way to see if the information you read about the reviews is validated or not without using a fact checker, right? Completely using software. And I think, yes, fact checkers have a role to play, but it doesn't scale, especially when you have end-to-end encrypted platforms like WhatsApp and others, which unfortunately become platforms for disinformation. So, it's one thing to deal with disinformation on Twitter, which is completely public, but quite another to deal with end-to-end encrypted platforms like WhatsApp. So what you need is mechanisms. By the way, when I was at Facebook, I built an offline messenger as part of my team. And what you need is mechanisms that use the blockchain-like solutions that these platforms already have. So for example, on WhatsApp Messenger, you must get the previous message, which has the hash and the key to decode the next message. So you can use those underlying mechanisms to actually see if the original information comes from a trusted source. So if CDC puts out a particular message saying, please go get your third booster because it's good for you, then it should be very easy to verify what is valid information. So I'm answering a question in an opposite way, which is by validating authentic information very easily, we can reduce some misinformation. Of course, there'll be misinformation from trusted groups, which are, let's say, a trusted group of anti-vaxxers can still do it as an organized effort. But at least for trusted public health organization, they can also put out messages that can be verified cryptographically when they're delivered, either in public platforms or encrypted platforms. And we have a whole paper on it if you're welcome to look at it.
Since you want to look at disease spread the way you look at traffic, I noticed that Google Maps, they sometimes make you take routes that let you explore around the area so that they can get information about traffic on other roads. So, I mean, for all I know, I'm guessing it may be hard to try to infect certain groups of people and see how that spreads. So how do you promote human behaviors to get data about how certain human behaviors can?
That's an excellent question. And, I spend a lot of time with vaccine makers. Dr. James Joshi has funded some of our work in this space. And the problem with Pfizer and Moderna and all these things is their cohorts. Just recruiting cohorts takes them weeks and months. And even after they do recruit a cohort, it's highly biased. It's usually healthy people who are willing to participate in this clinical trial. So it does not represent, the general population, a 70-year-old with 3 comorbidities and so on. They simply are not able to recruit those people and see the effect of their vaccine. So what pharma and vaccine players would like to do is exactly what you mentioned. I mean, when I was at Facebook, we run thousands of A/B trials every minute to figure out which shade of blue is good for the Facebook banner, for example. And that ability is simply not available to public health to run all these A/B trials. And like you mentioned, it's possible to nudge people with some warning that if you participate, we'll send you on different trajectories of your pandemic journey, either incentivize them or even give them cash. But you can do all these cohorts and do these arms of the new term in clinical trials is decentralized clinical trials, which is a similar idea to what we just discussed. So absolutely, I think we need to create these computational tools for public health so that humans become sensors.
When you have, but to send people off their pandemic trajectories, you probably want to send, I guess, healthier people because you don't want people to have severe complications. So wouldn't you need people's personal data to find out what health conditions and age each person is?
Yeah, I don't think I heard the last part of the question, but it's something on the lines of when you do send people on these trajectories, how do we deal with the personal data and so on? And I think the opportunity here for us is imagine if all of us got an alert in the early days of the pandemic and vaccine development saying, hey, do you want to participate in a clinical trial of this vaccine? And cohorts would have been created in many ways, incentivized in many ways, and so on. And then again, in a completely privacy-preserving way, we could just show up at a center, get the placebo or the control shot, and then kind of report our trajectories. And if the exposure notification was tied to this thing, I mean, again, it's disappointing when you saw the first results from Pfizer and Moderna, they had of the order of under 100 people infected to declare victory, right? They had about 30,000 people in their clinical trials, but less than 100 people were infected, and a smaller fraction were infected after vaccination, and about 100 were infected without vaccination for them to get the emergency use authorization. And that's why a lot of the issues we see later on do come up. Again, we want to create trust in the public health interventions. And if you're going to spend billions of dollars behind the science, let's spend at least $2 million to get the software behind it right.
So the app you just described in this presentation has been deployed in China since a long time ago, and is very, very mature. And it tracks people's mobility, health status, vaccination, and some other stuff. And the most important part in China with respect to this app is that they invented a so-called time-space tracking method. It means that, okay, utilizing the mobile network, suppose that you are using cell phone and I'm using cell phone, and you have installed the app and I installed the app as well. And suppose that within a certain range, and I may not directly contact you, but we may locate in that predetermined region with a certain scope or range simultaneously, then we will be considered as in contact with each other. And this mechanism invented by China would consider this context as such type of context as a potential risk for the spreading of the virus. And in that case, there will be the pop-up window or sort of a notification shown up in both of our apps. And this notification will not be clear unless we do some consecutive PCR tests within a certain required range, like 2 weeks or 3 weeks, so that we can clear that notification. And so, of course, the condition to clear that notification will be consecutive negative results.
Exactly.
But,
I see where you're going. And this is the point I made earlier, which is we can learn a lot from other countries, especially the Asian countries who did deploy some of these apps, especially if we can solve two sub-problems, which is how do we prevent it from slipping into a big brother system? And how do we make sure that the privacy preserving technology becomes so privacy preserving that it doesn't help the public health, right? And the opportunity for us here, computationally speaking, is to actually really deal with that, right? Like, how do we create this no peak privacy solution that's not coercive and doesn't become big brother? And as you said, getting this definition of close contact using purely technology is not possible. Just like using Uber or e-commerce to detect what should happen when. It has taken years for these companies to get it right. And similarly, close contact, which CDC kept on changing its definition, but technology would have helped us understand what a close contact means. Is it a person within 6 feet for 15 minutes, or the same room, or same building? We still don't know what a close contact means, depending on the variant and the transmissibility and virulence of that's out there. So even a definition of close contact can be improved over time in that sense. And like you said, I think if you have a single app that allows you to track the pandemic trajectory in a privacy-preserving way, then we can create this all-seeing, all-knowing public health system that's out there, as long as we solve the problem of computational privacy and no coercion. So we can learn a lot from these other systems as well.
Okay, just a minor follow-up question. So do you think such kind of apps, if your pen or such kind of things had been deployed nationwide and everyone required to install such kind of apps, but the pens, of course, will be public and everyone will know that. Don't you think doing this will cause some social anxiety?
Yeah, exactly. I think if you saw my scorecard of how to look at an app, the number one is how do you create that trust? How do you create that privacy? And using government branding for a public health app is a completely bad move, especially in Western democracies. For some reason, people are willing to share everything with Facebook and Twitter and Google, but they complain, even on those platforms, that their privacy is being invaded when you have to do vaccine credentials by the government. So these companies magically have created a brand that people think, at least some companies have created a brand where people are completely willing to share their data because they have a good track record. So it's, again, getting this right is not going to happen overnight. It's going to take many years, and there are going to be fumbles in the beginning. NHS UK is a good example where they went back and forth about how much data to collect and who has access to that data and so on. And so we have to get that balance right. The good news from a research point of view is that is no peak computational privacy methods will literally create this enterprise grade security and privacy for us, so that we never, ever, 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 ever had to give up any information about an individual and still get extremely high fidelity personalized response. So that's the amazing power of no peak privacy. And this should be front and center for any public health solution going forward.
I can be quick. So you have, I'll just call them customers at the individual level. You have customers at the government level. And the question I'm asking has to do with customers for what? And so as I see this information that you're talking about coming up, it is situational assessment style information. It establishes context at different levels, the individual level and the government level, whatever. So the question, though, is, do you see supporting individual decisions? The decisions made at the national level are very different, and different agencies, they're very different than all the details associated with a particular individual in a particular context. Do you see actually developing capability to take the input from the state assessments and actually deliver recommendations for individual behavior.
Absolutely. I mean, the reason Waze works is not because Waze publishes traffic density maps every minute, but gives you highly personalized information whether you should take a left turn or right turn right now at this intersection, right? You don't have to go and read some paper to say, hey, maybe I should get my third dose because maybe now I'm eligible for it and maybe it's good for me. It tells me right now. And if I trust Waze, I will take the left or right turn right now, even though I know every day I take a left turn. And that's the kind of trust you need to build in these apps and create highly personalized, just-in-time information that's delivered, that's high fidelity over time. So I think that's the real magic here. And this is a challenge that public health faces. There's a very nice talk given by Robert Redfield, the previous director of CDC, where he compares kind of medical systems versus public health systems. And the challenge for us in this pandemic is that we have been thinking of this pandemic as a medical clinical problem as opposed to a public health problem. And as the previous individual who asked the question about Asian countries and so on, pandemic is a game of statistics, which means you have to get it mostly right and you have to bring the R naught below 1. It's not important to be so coercive that you penalize every person. All you have to do is create an overall societal behavior so that your R naught goes below 1, and within a few days, the pandemic will be tamed.
Well,
So
with all respect, I understand your answer. I understand this part of your answer, but the individual needs to be assured that they will receive not statistical benefit, but actual benefit from their decision. And the public official also has to understand that if people follow these decisions that are being promulgated individually, that they in aggregate, in fact, do yield to the national policies or whatever it is, policies that they intend. And both of those things are what I'm saying. That coordination is, I think, very, very interesting, and it's different to make decisions than it is to make state estimates. And I just thought I would.
I was just getting to that, using Waze as an example of instant gratification. And so, behavior scientists we have on our team, I mean, this is a game of behavior science, right? And the reason why things like Web3 are taking off is because they really deal with the incentive structure really well for now using tokens and cryptocurrencies. But I think creating those behavior mechanisms, whether it's through insurance plans, whether it's cash payments, whether it's promotion at work, whatever those carrots and sticks you need to change the behavior is very critical. So that's another major area of research. Behavioral science is very well known, but how do you do that in a privacy-preserving way so that an individual is nudged and gets those benefits without revealing that they're participating and they're getting those benefits?
Amazing talk. Very eye-opener for us because we are not in that area, but seeing it from other end, what challenges you face in developing something like that and how you are building it and your philosophy, the way of thinking. So thank you.
Frankly, it's very humbling. All the ambitions we had, we just learned so much of how the systems work, what's possible and what's not possible. It's actually a very humbling journey so far.
Yeah. Well, one thing I noted in your talk was you crystal clearly, at least in this slide, you crystal clearly pressure points in the system and what are the challenges, you clearly articulated it and addressing those ones, which we know for a long time, but I don't know why people have not been, because there has been pandemic in past, like Ebola outbreak, and SARS-1, COVID-1 outbreak. There's so many outbreak has been, H1N1 outbreak has been, flu happens all the time. But why didn't we think it earlier? And now we are in that regard. So
and to be honest, the experts have actually made the situation difficult, because I had a great chat with Robert Redfield, the previous director of CDC, and he said, Ramesh, the 15 people who sit around and advise CDC, they don't think like you. They don't think about software. They don't think about consumer technologies that can make an impact. So experts who have worked on Ebola and HIV actually come in the way, despite best intentions, because saying, this is how we deal with outbreaks. We create call centers, we do contact tracing, we encourage science to do vaccines, we do public messaging, we buy slots on TV and radio and newspapers. This is how it's done. And I think the challenge with today's world is that, first of all, this pandemic has a very different scale. And second, that the citizen behavior is very different. They are not, today's citizens don't trust the government at all. They trust other mechanisms. So The way we did with HIV and Ebola doesn't necessarily help us with how we should deal with this pandemic.
But I think your point was that we can crowd share some of this information, which has not been taken care of for public health. I would wonder, these clinical trials for pharmaceutical, that has been for long literature on it. And this is very kind of bread and butter for pharmaceutical companies if they don't do these clinical trials. Clinical trial is just a sampling study, what you are talking about, 1% of people who are putting the data. So how are they doing it successfully and we are unable to do it for a public health?
They're doing it with a lot of money. They still use traditional mechanisms to recruit cohorts. They go to church groups. They go to cities. They call up their contacts at hospitals. They try to recruit them. They keep track of them. If you've seen the app that was given by these pharma companies to 30,000 people who in their cohorts, these were apps that would be built by a high school student in 2 days. Those kind of apps that were given to them saying, hey, every day in the morning, send us your symptoms. They have this and that. There's no engagement, no incentive, and so on. So it's to create that all-seeing, all-knowing system is very challenging. Also, those apps that were given to people in the clinical trial cohorts, they're not connected with exposure notification. So there was no way for them to know whether they got sick. They didn't get sick because the vaccines worked or because they were never exposed, right? So they have to wait till the end of the clinical period and then do a statistical analysis saying in a given county, if X number of people are infected and Y people are not infected from those two arms, they're using statistical mechanisms to do that, but they could shorten their clinical trial period by a significant factor if they used a closed loop system like this. I mean, the same way Uber knows how to do search pricing in a matter of minutes is same thing, as opposed to taxi unions who might take a year to figure out that they should charge more for one bridge or the other.
And I was just going to add to this conversation while we're going off here a little bit, that when I was at Sick Weather, we did a clinical trial engagement with Radiant Clinical Trial Organization to get people enrolled in a cold cough flu, like nasal spray remedy. And the challenge for them was to actually get people who were symptomatic with cold symptoms within a very short window and period of time. And the only way they were really able to do that was to leverage a platform where it's like the sort of Waze app for health that you're talking about, where as soon as someone reported that symptom, they were served up with that clinical trial invitation, as so long as they were near where the clinical trial was being held. And they found that the conversion rates in that context and that kind of platform were much higher than all their traditional conversion rates from advertising on TV and radio and even like direct mail and refrigerator magnets for people who had been in clinical trials previously. So it's an extremely powerful tool if it can be done at scale.
By the way, Graham is the president of the PathCheck Foundation, which is the one deployed this app for millions of users in multiple US states.
Can I ask you also, Dr. Raskar, about any article on how Uber is doing all these things? So, I mean, you are telling me these things, then I'm realizing oh, wow, these people have been a successful story, but in a different field and how they are doing it. So is there any article that discusses all these challenges and how do they fulfill these challenges?
I'm sure there are many articles out there because Uber is a very progressive player in the data science community and they release data to cities to help them manage their traffic and so on. So I'm sure there are a lot of papers. I can't think of like a single document that I can point you to, but there are plenty of papers written by Uber as well as researchers who use the Uber data. And there are separate case studies on how Uber runs its backend infrastructure, the physical infrastructure for it. A lot of the insights I have gained are actually by talking to top C-suite leaders at Uber, how they think about what is problems.
Okay. Thank you very much. I just wanted to say it was incredibly eye-opening talk and the way you presented was also amazing. So thank you.
Sure. Thank you.
One thing also, Dr. Raskar, I've realized is in academia, the thinking as a product is also, we think as a new research, but thinking as a product, which is useful for a common public is also that the thinking is different a little bit in academia than probably in the MIT that has been engraved in people from the very beginning.
Yes and no, because we did everything in academic setting for the first, say, month or so, but then we had to eventually spin it off as an external entity, and only then we could think of it as a product. So yeah, I think there were people who had a product mindset, and in fact, I was very lucky. Just like Graham, I had like 5 ex-CEOs who have run large companies join the professional volunteer group, and they, of course, had really thought about how to create consumer-facing products out there. So because of them, and of course, hundreds of additional volunteers, it was possible to make it happen.
But what I'm saying is that maybe MIT has a mechanism of you spinning off a company like that one, but maybe
It's a 501c3 nonprofit, so it's not a company.
Mhm.
But you're right that even to spin it off, I needed the external talent who can take it on, because I can only provide the leadership and the technical background and all the connections, but somebody else has to go and actually build the product and make sure it's enterprise grade.
Just to let you know that we have coined this term called P-cubed analytics, pervasive, personalized, and precision analytics. It is something we at least hope to build out as a part of this project, and we can talk more. But I really want to thank you. Thank you very much. We really appreciate this absolutely amazing talk. I think many questions remain in the audience, but we'll have to stop because of time. So thanks again.
Thank you.